Assalamu alaikum. We want to study in this video the alkenes. So the objectives are represent the addition reaction of hydrogenation, halogenation, and hydrohalogenation and hydration. So recall back, the general formula of alkene is CnH2n, characterized by the presence of a double bond in the carbon chain. Number the chain so as to include both atoms of the double bond and begin numbering at the end of each chain near the double bond. There are two kinds of isomerism, positional and skeletal isomerism. Introduction. Why do alkenes undergo addition reactions? Alkenes are unsaturated molecules, which means they do not have all the hydrogen they could have. This is because there is at least one double bond between carbons. This is a stable structure, but not the most stable. So when certain compounds or elements are added, like bromine, they undergo an addition reaction. Like this, for example, ethene plus bromine give 1,2-dibromoethane. Reactions. Unlike alkanes, alkenes are chemically reactive. This reactivity is due to the presence of double covalent bond in the molecule of the alkene. So the presence of the double covalent bond indicates the reactivity of the alkene. Addition reactions. Alkenes undergo a characteristics reaction, which is addition reaction, where a molecule of XY can be H2Cl2, Br2, HCl, HBr, and others, is added to a molecule of an alkene according to the following schematic representation. Here we must pay attention that we must add XY on the double covalent bond and on the carbon atoms just next to the double covalent bond. So we must add X on the first carbon atom and Y on the second carbon atom, and we must break the double covalent bond so the double covalent bond becomes a single covalent bond. Catalytic hydrogenation of alkenes. Hydrogenation means that we must add H2 to the alkene. The hydrogenation reaction of alkenes, consists of adding a molecule of hydrogen, H2, according to the nomenclature, hydrogenation, to a molecule of alkene. If we want to take the general formula, the general formula of alkene is CnH2n, and we must add H2. So the two hydrogen atoms must be added on the hydrogen atoms of the alkene. So the product becomes CnH2n plus 2. Okay, and here we must pay attention that we must use catalyst, nickel, platinum, or palladium, and in presence of heat. So by hydrogenation of alkene, the alkene becomes alkane. Condensed structural formula. If I take, for example, the propene, and I want to add H2 on the propene, the mechanism is we must add H2 on the double covalent bond and on the carbon atoms just next to the double covalent bond. So we must add H on the first carbon atom and the second H on the second carbon atom, and we must break the double covalent bond to become a single covalent bond, and the product becomes CH3, CH2, CH3. So the propene becomes propane. And remember that we must use the catalyst. The halogenation of alkene. The second reaction is the halogenation of alkenes. Halogenation means halogen, X2. It can be Cl2, Br2. So we must add here Cl2 or Br2, any halogen, on the alkene. Halogenation of alkenes consists of adding a molecule of halogen X2 Cl2 Br2 to an alkene molecule. If we take the general formula, we have CnH2n plus Cl2. We must add all the Cl2 on the alkene and we obtain one product. For all the addition reaction, we obtain one product. So if we add Cl2 on the alkene, the product becomes CnH2n Cl2, and the nomenclature of this product is dichloroalkane. It is an alkyl halide containing 2 atoms of chlorine. The condensed structural formula of propene, for example, and we must add Cl2 on the propene, so we must add as mechanism on the double covalent bond, and to the carbon atoms just next to the double covalent bond, we add Cl on the first carbon atom and Cl on the second carbon atom, and we break the double covalent bond to become a single covalent bond. So the propene becomes 1,2-dichloropropane. Why 1,2-dichloropropane? Because we must begin numbering nearer to the halogen atom, like alkyl group, for example. So we must numbering from here 1, 2, 3. So the position of dichloro is on the first carbon atom and on the second carbon atom. The nomenclature is 1,2-dichloropropane. For the third reaction, hydrohalogenation of alkenes. If I decompose the nomenclature of this reaction, I found that is formed by 2 parts, hydrogen and halogen. So hydrohalogenation of alkenes consists of adding one molecule of hydrogen halide HX, it can be HBr, HCl, to one molecule of alkene. If we take the general formula, for example, CnH2n plus HBr, I want to add HBr on the alkene. So I want to add H first on the hydrogen atoms of alkene, and it becomes CnH2n plus 1 Br. Okay. And we obtain an alkyl halide formed by one atom of halogen. The nomenclature is a bromoalkane. What is the difference between the second and the third reaction? On the 2 reactions we obtain the alkyl halide, but on the second reaction we obtain an alkyl halide containing 2 halogen atoms, but on the hydrohalogenation of alkenes we obtain alkyl halide containing one atom of halogen. If we take the condensed structural formula, I take the ethene, for example, and I want to add HBr on the ethene on the double covalent bond as mechanism, and on the carbon atoms just next to the double covalent bond, we must add H on the first and Br on the second, or H on the second and Br on the first, it's the same, and we must break the double covalent bond to become a single covalent bond, and the ethene becomes bromoethane. For the fourth reaction, hydration of alkenes, hydration means H2O. So we want to add H2O on the molecule of alkene. But we must decompose H2O into parts HOH, and I want to explain why we do that. The hydration reaction of alkenes adds a molecule of water, HOH, to one molecule of alkene. If we take the general formula, for example, CnH2n plus HOH, we must add H on the hydrogen atoms of alkene, and the compound, the product becomes CnH2n plus 1 OH. Why OH? Because OH represents the functional group of alcohol. So So the general formula of alcohol is CnH2n plus 1OH. If we take the condensed structural formula, for example, we take the ethene plus HOH, and in presence of catalyst or H3PO4 or H2SO4, we must add first H on the first carbon atom and OH on the second carbon atom. These two carbon atoms are just next to the double covalent bond, so the product becomes CH3CH2OH. For the nomenclature of this product, it is an alcohol because it contains a functional group OH. So the prefix of the nomenclature is like alkane, and the suffix of the nomenclature is all like alcohol. So the nomenclature becomes ethanol. Summary: the alkenes undergo a characteristic reaction, which is addition reaction. The hydrogenation reaction of an alkene produces an alkane. The halogenation reaction of an alkene produces an alkyl halide. The hydrohalogenation reaction of an alkene produces an alkyl halide. The hydration reaction of an alkene produces an alcohol. Homework: the book of chemistry, page 273, number 5 without mechanism, page 274, number 9, part A, B, C, D, number 10, part A, B, C, and number 13. Thanks for your attention, وإن شاء الله بشوفكم على خير يا رب.